So, hi guys, welcome to this newest video. My name is Johan, and together with me is T-Rex. He is one of the co-founders of Liquidware. And T-Rex, you kind of already drew something on the board.
I did.
What would you like to share with us today?
Well, what I wanted to share today is, in our market of end user computing, there's a tremendous number of things that are happening that are both disrupting, changing the market, and offering opportunities to those that are consuming, in general, Microsoft technologies. So what I started with here were just a couple of endpoint devices. I've got a laptop, I've got what I'll call a thin client, and then I've got a full stateful desktop. And the reason I drew these up there is that there's some dynamic shifts that are happening in the market around the way we're going to deliver Windows. And so what I thought I'd do is just kind of lay out the typical architecture of a full PC and then kind of use that to bridge the gap to where we may be going and kind of some of the new non-persistent, ephemeral, maybe even cloud-based models of the future, if that'd be okay.
Right, yeah, sure.
Cool. So what I usually start with, and this is a pretty simple explanation, and stop me with any questions as you go, is what is a PC? Well, I think a PC is actually the summation of a couple of very interesting moving parts. First, I've got the user's profile. I'll just use P to stand for profile. It's the things that you've done to customize these devices over the years, your filter, your background, your browsing history, your MAPI profiles, what admins want you to have for printer access, these types of things. It's the goodwill that you've built into these PCs before we take them away and refresh them every 3 years.
Something that basically makes the user experience become persistent.
Yeah, absolutely. Yeah. Persistent, personal, and I think it's a productivity. So there's a lot of P's in there. Okay. So it reminds us with profile. Next, I'm going to draw D. D stands for data. For far too long, we've had data as statically installed component. It lives on the devices that we've chosen. It lives there for 3 or 4 or 5 years, rarely backed up, if ever. And so, one of the things I like to think about is what can we actually do with data? Well, users do two things with it. They consume it or they create it. And what we use to create or consume that data are apps. Okay, so my profile is the customization, my productivity. I use the applications installed, statically installed in the PC to create or consume data. Now, all of this historically has lived on an operating system, which has then lived on x86 hardware, and I'm just going to put some local storage down here. That was the monolithic desktop of the past. Now, there were some good things about this. I don't want to make it seem like this was, for the most part, a bad architecture. This became progressively less expensive as time went on. We call that Moore's Law. There definitely were advancements in automation around, not only how to lower the cost of the hardware, but how to update and patch the operating systems, the apps, the profile, and the data. But the problem is this. The problem is, what if I lose one of these components? If I lose my profile because it becomes corrupted, I've lost the rest of the functional use of this PC. Yeah. I'm out of work. I'm not productive at that time. If I lose my data, either because of theft, or I erase it, or it's not being backed up, again, I might lose the workflow of the content I've either been creating or consuming. Applications, again, these are statically installed on the hard drive of each one of the PCs that we've historically used. So things like updating, patching, securing, I have to have a one-to-one relationship with every PC on the network to be able to handle that. And not to mention there's 4 million independent software titles out there. I know, I couldn't believe that myself, 4 million. So we draw an X through that. Now, what we're left with is an operating system and x86 hardware. So I said to myself, what if we took this apart? And this isn't just me saying it, this is kind of the promise, the notion of trying to make these monolithic, persistent devices with all of this embedded in them maybe a little bit less persistent. And so what we do is we say, okay, let's have the discipline to do the following. User profiles are always going to do one of the two things. They're either going to live on a file server in the data center, right? Let's just say this is the data center or the cloud. Because here I can manage them as a fleet of profiles. I don't have to have a one-to-one relationship with your profile on your PC. I now have central access in the data center. I can also do some interesting stuff. As this is typically on shared storage or object-based storage, I can now replicate this. So I've just done DR of my profile. Next thing I want to do is say, there's a reason we named it the data center. Maybe that's where data needs to live. Yeah. So let's do that for a second. Let's just hypothetically have the discipline to say that data is never, again, going to live on the hard drives of devices. It's going to live in the data center. So we go ahead and draw our block here, put our D in, and again, this is going to live, I'll just draw this a little differently, either in shared storage in the data center or, again, object-based storage in the cloud.
If you talk about profile again, so what makes the way you would like to implement a profile different from using roaming profiles, for instance? Because as a VDI architect and as someone who does a lot of consulting in this area, we do see a lot of challenges with roaming profiles in general. Profiles getting corrupted, the profile itself is being a monolithic thing, and as soon as one application or one service or one file gets corrupted in a profile, you're not able to work anymore.
Yeah.
So how do you...
Great question. It's really the core of a lot of this, which is this was worst case scenario IT. Put every core, every socket, every piece of application that you might need in this monolithic device, including the user profile. This is more of a just-in-time model, which is why would I force feed or force stream or commit to pulling down into a local profile something that I might not need all the time. So whether it lives in shared storage, when it lives in cloud, I can take bits and pieces of my user profile and actually treat them somewhat different as well. Example would be a policy that the administrator wants to enforce on everyone.
Right.
Well, if I do that on a single desktop, I might have an erroneous effect. The other thing with roll forward and roll back, becomes more possible. Picture a use case where you have thousands of profiles that become corrupted either simultaneously because of a poorly written application, some other phenomenon that happens in the company. It's very, very difficult to do that on 1,000 physical devices. One thing that virtualization taught us was when you abstract, you actually gain a certain degree of freedom. The ability to do things with right clicks instead of calling up and ordering products. Hopefully that answered your question.
Makes sense. Totally
the
makes
same
sense.
thing with data, quite frankly. I don't know many desktops that are fully deduped. From the standpoint that when I get data over on this side of the equation, I start having an aggregation benefit. What I mean by that is, wouldn't you love to be able to data mine across all of the hard drives of all of your users? 70% of the intellectual property of most companies lives on the hard drives of these things over here. And yet it's landlocked. It's not secured, it's not backed up. It's spinning at 5,400 RPM, and I can't search it.
Yeah.
I remember one product a while ago. Remember the Google search appliance? I always thought that was pretty cool to be able to, index and archive and retrieve the value from all the docs and data and information there is pretty key. Here's where it gets really fun. We haven't talked about apps yet, so I'm going to draw a big circle around apps. I'm going to actually circle it a couple of times, and the reason we do this is actually not new. We've been trying to remove applications from operating systems since Citrix was first, introduced into the market, since terminal services. WinFrame, absolutely. The idea of saying, for one of two reasons, either because I need remote access to that application, or there's some kind of contention with that app and other apps in the image. And here's why this is important, in my opinion. We've heard from Microsoft that Windows 10, 11, 12, whatever you want to call it in the future, will be progressively more non-persistent. It's going to be updated and patched and innovated at a much more rapid pace. So it actually behooves all of us to try to get the profile, the data, the applications, out of these historically persistent and monolithic models into something that's a bit more flexible. Because here's where it gets kind of fun. Now, what we've left is the operating system and x86 hardware. I actually believe this can be operated in a number of different locations. We can erase the center here. I'm going to do this. That's a lot of writing.
Yeah, that's okay.
All right. Now, this might be a little messy, but we're almost there. All right. What I'm going to draw right now is just your most basic VDI architecture. So now that I've got my profile, my data, and my apps abstracted from the monolithic, this middle part is the opportunity. So after we consider doing on-premise VDI, again, the power is in abstracting these things away from the physical desktop in the first place. There may be a use case where we only want a component of this to come back. There are a number of new application publishing options out there. So if I look at, let's talk about cloud for a second. How's that sound?
Yeah, sure.
So one of the, I think, popular conversations right now is around workspace as a service, or desktop as a service, or application as a service, all coming to us from the cloud. And it doesn't really change our architectures that much. Now, I drew over here standard Windows file servers, where in your normal data center you would store these things and treat it as a number of consistent data objects and manage it as you would the rest of the elements in your environment.
At the end, it doesn't really matter where the container or the OS that you would like to load these on lives.
Exactly.
So it could be either in like an Amazon hosted desktop or in VDI or on a physical endpoint, right?
You're exactly right. I mean, this new model and the way we think about this in terms of abstraction is, It doesn't matter if it's, say, Workspace ONE or Horizon running on AWS. That doesn't change the fact that if we go to cloud, and I look at the model and I say, okay, I have some kind of x86 hardware. It might be cloud, or it might be a physical device, or it might be a workspace as a service offering from any of the cloud vendors, right? And then I need an operating system. And so, that's the good news is offer it as a service from a number of the cloud vendors, or if I'm bringing a VMware environment onto a cloud, this is literally just VDI on the cloud, or DAS as we like to call it. And again, I just want to point out that this is the element that Microsoft has made it very clear is going to be innovated at a much more rapid pace. So again, it behooves us to get these elements back. And again, what I'll do is, I draw these as kind of dots now, because my profile, my data, and my apps are now the probability of those being ready when and if I need them. Again, there's no reason to bring all my data into this ephemeral architecture if I only need one set of documents or one set of data. There's no reason to own and patch and manage applications for every one of your 10,000 users if only a few hundred at a time need to use that app. And I think what you find at the end of the day is you have an incredible amount of agility, and you're really putting the people-centric nature back in IT as opposed to the device-centric nature that we've been working on. That's one of the things that we're working on at Liquidware. And of course, as you're talking about these different architectures, visibility is key. What does better mean? Better, does it mean faster launch times? Does it mean I use less I/O, less storage? I don't log in as long? All of those qualitative and quantitative things we think are incredibly important for organizations that are deciding which one of these architectures might be right for them.
Mostly because user experience is key in every project that we run. So being able to get that user experience that the end user is expecting is viable. And I do believe that a non-monolithic approach of application and profile delivery and data delivery obviously is essential. So cool.
Absolutely.
Okay. Thanks.
Thanks for your time. Appreciate it.
Well, if you guys have any questions about this methodology of delivering the applications, data, or profiles, if you have questions about Liquidware solution in general, or how we could help you in getting a methodology like this done, reach out. Here is my email address. Here is T-Rex's. And thanks for watching. See you next time.